Hey everyone, it's Mr. Han here. Here are our notes on how to determine the slope from a graph. So today we're going to be given graphs and your job is to find out what the slope is. Now, slope of a line is how it's changing or how it's growing, right? Y equals mx plus b, so m is our slope. And here, what does slope mean? Slope, it just tells you how steep a line is and how slanted the line is. It also tells you what direction it's going. Is it going up or down, right? And remember, we always read graphs from our left to our right. So left to our right. I know that this is flipped, so I'm going this way, but we read from our left to our right, okay? Hopefully that worked out right. But if you look at on the big screen, right, left to right, okay, just like how you read your words from left to right, we're going to look at our graphs from the left going to the right, left going to the right, okay? So slope is going to tell us how steep a line is or how slanted the line is, and it's also going to tell us what direction it's going. Is it going up or down? And that's very similar to association. If you remember talking about associations, right? As the plant gets more water, right? As it gets more water, it'll grow. So, how do we find the slope using a graph? And that's our question today. We're going to follow these steps. It's pretty simple if you can follow these steps. So first thing we need to do, find two lattice points. Now, if you don't remember lattice points, we can look. These are lattice points right here. And we've had notes on this already. These are all lattice points. They're all where the cross is, right? But we need to find the lattice points of the graph. So we're going to look at number one, right? We're going to find a lattice point, and here's another lattice point. Here's another lattice point. Okay, so that's our job. We need to find at least two lattice points. Okay, so we need to find at least two lattice points. That's the first step. Okay, second thing, we're going to draw a growth triangle or a slope triangle. So here, the word slope, instead of using growth, we're going to say slope. And so we're going to go ahead and find a slope triangle, okay, and connect the 2 points. So let's go ahead. Oh, here, I'll finish reading the instructions. Number 3, we're going to count the change in y and change in x. So how much is it changing on the y-axis? How much is it changing up and down? And then how much is it changing on the x? How much is it changing left to right? All right. And then the last thing we're going to do is write the slope as a fraction or a ratio. So this right here, we're going to write the change in y over change in x. Now, that might sound very confusing to you, but all it's saying is between the 2 points, right, the two lattice points that we find, how's it changing on the y-axis? Is it going up? Is it going down? By how many, right? And then how much is it changing on the x? And we're going to go ahead and use that. And this triangle is just saying how much is it changing? This means change in. So change in y over change in x. And then you could also call it rise over run. And I'm going to explain all this in just a second. Okay, we'll come back to this. Okay, I'll come back to that, but I do want to make sure that you understand these steps right here. So let's start with the first step. Find two lattice points. I'm going to go ahead and take my pencil and mark a lattice point, which is right here, and right here. So I have 3 lattice points here. I really only need 2. And what I'm going to do is I'm going to draw a growth triangle or a slope triangle connecting the 2 points. So here, I'm going to go over to the right and then go up however many it says. That's 1, 2, 3. So I drew a growth triangle. Okay, that's ugly growth. Okay, there you go. I drew a growth triangle. And you could also draw a growth triangle from here to the next one. And hopefully this is familiar to you from chapter 4. Yep. All right. So we went ahead, we found 2 lattice points, check. We went ahead and we drew a growth triangle, a slope triangle, okay, creating a right triangle, creating a triangle. Right here, you can see that there's a triangle. All right, now we're going to count the change in y and change in x. Well, how much is it changing on the y and how much is it changing on the x? So let's go ahead and count the x, right? The x is growing by 1. It went from -1 to 0, or 0 to 1. That's 1, right? So each time it changes on the x, it's going over 1. So that change in x is 1, okay? It's the x value went from -1 to 0, right? So the x grew by 1. So technically you could say plus 1. And then how much is the y changing by? It's going up by 3. So our growth triangle grows by 3. Okay? And you can see that it's consistent. Over here it grows by 1. And then it goes up by 1, 2, 3, plus 3. Alright? So we're going to go ahead. That's as simple as it gets. Okay? And what we're going to do is we're going to write the slope as a ratio or a fraction. So here, slope, m. Change in y. What was our change in y? How much did it change by in our y, right? Change in y equals plus 3. It went up by 3. 1, 2, 3. And our change in x was plus 1. Right? Plus 1. So our change, how much did it change? How much did it grow by? And how much did it change into y? So right here we have our change in y and change in x, and all we do is we write it as a fraction. So I'm just going to write it as 3 over 1. And if that was confusing, change in y equals 3, change in x equals 1. So we can say 3 over 1. And that's going to be our slope. That's our m. And if you remember, that's kind of how we did our growth triangles in chapter 4. Now, you can also say rise over run. And actually, I'd like to use that a little bit more, right? How much is it rising? And I want you to think rise. When you lay in bed, what do? You rise up, right? And so that's going up and down. How much is it changing in your up and down? Rise. And then run, well, you don't really run like this, right? You run across. So run is going to be on the x-axis. How much is it changing? That's what it's saying, right? On the x. And then rise is up and down. So when you think of rise, I want you to think of getting up out of bed. Right? So how much is it going up and down? So it's going to go up and down. And then run, you're thinking of a person running. And it goes from left to right. Okay? That's basically what we're trying to communicate here. So rise over run. So how much did this triangle rise by? It rose by 3, and you run over 1. So rise over 1 is 3 over 1. So our m here, m equals 3 over 1, which is the same thing as 3. So our growth here, our rise, our slope, right? We're going to start using the word slope every time now. Our slope is 3. And it's a positive 3. So you can also see that the line is going in an upward direction. Okay? So I'm throwing a lot at you right now. Let's go ahead and look at this one. We need to find 2 lattice points. So we're looking at this one, but I'm going back over here. Find 2 nice points. So let's go ahead and find 2 lattice points. Is that a lattice point right here? Can you call this a lattice point? I don't think so, right? Is that a lattice point? No. Right here. There's a lattice point right there. So I'm just going to follow the line. No, no. Here, yes. And our lattice point here. Okay. So I'm going to go ahead and draw a triangle. I'm going to go over to the right. And notice that the line's going down, right? It's the line's going in a downward direction when you read from left to right. So it is a negative slope. It's going over 1, 2, 3, and it's going down 2. I could do another growth triangle here. It should be the same. Should be the same. Goes down by 2 over 3. So what's my change in y, or rise? And what's my change in x, or run? So what's my rise? I'm gonna move this up. Nope, I'm gonna move it down. Nope, I'm gonna leave it right here. So sorry. All right, rise, it's going down by 2, and run, left and right, is going over 3. So my m is negative 2 over 3. All right. And then technically I could also find out what the equation of this line is, right? If I know the M, I also need to know the B, and the B is technically right here. Okay. So I could find the equation, but not going to worry about that today. That's just so you know, that's what we're doing. All right, let's go ahead and find the slope of this line. Oh yeah, slope of this line. Let's find two lattice points. Here's one right here. That is not one. 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 But that is one. Okay? So I go up and over. So the rise is 1. Oh, look at that. How is this scaled? By 2's, right? So this is technically 2. And how much is this scaled? 1, 2, 3. So it goes over 3. So what's my rise? Change in y equals 2 over change in x, which is 3. M equals 2 over 3. Alright, so find two lattice points. How much does it change up and down? How much does it change left and right? Alright, rise over run. Last one. Find two lattice points. I see one right here. I see one right here. And we only need 2. Okay. But if you find 2 of the closest ones, you don't have to reduce. So here, no, here, no, here, no, here, no, here, no. Here we go. Okay. So goes over. Let's try that again. So here it goes over 1, 2, 3, 4, 5, 6. And I did notice that scaled by 1, so it is actually 6. And in here, this is scaled by -2. And you can see that's -2, -4, -6. So the value here is -2. Okay, so what's my change in y or my rise? Change in y up and down. How much does it change by between these two lattice points? -2. Change in x or my run. How much does it change from left and right? If I were to run this, right, left and right, it'd be over 6, and that's all it is. M equals -2 over 6. Ooh, now I did say if you find the two closest ones, you don't have to reduce. But because this is scaled by 2, technically this might have been the lattice point if it was scaled by 1. So here we could reduce this fraction. I could divide both by 2. So this can be reduced. Or here, let me show you. I'm going to divide by a giant 1. So anything divided by 1 is itself, right? But if I do 2 over 2, that's the same thing as 1. Then I could go ahead and reduce. -1 over 3. 2 divided by 2 is 1, but it's a negative. So -2 divided by 2 is -1. And then 6 divided by 2 is 3. So here's my final answer. M equals -1/3. And so if I give you a slope now, that's a fraction, hopefully you know that you're going to rise -1 and you're going to run 3. And so that's actually a concept I need you guys to start learning, rise over run. And so I teach it like this. You can't run until you get up, right? So always do rise first, get up first. If I were to chase you down, if I were playing tag with you and everyone would start off laying down, right? You're not going to run on the ground. And in class, technically, I would lay on the table and start running on the ground, but not in class right now. So, well, I'm in a video. So here you go. That's how you find a slope if you're given a graph. So determine the slope from a graph. Now, I did say we're going to come back to this, so go ahead and zoom in here on these two. All right. If the line goes from left to right, if it goes up, right? The line goes up, the slope is, it is a positive slope. Okay, so it's going in an upward direction from left to right. If it goes up, it's a positive slope. If the line goes down, right, like this one right here, if it's going down, the slope is negative. All right. All right, this was a short set of notes. Your job is to find the slope given a graph. Okay, if you have any questions, please let me know. On a scale of 1 to 5, I want to hear from you, so go ahead and let me know.